You have learned about primitives and how you pass them inside of methods, i.e. by value or reference, and you know internally how they do work. So right here, what I want to show you is, you see that we have integer, so number equals to 1, right? But this guy right here is a primitive, right? So if I say number dot, I don't get any methods associated with it. So if I want to work with this integer in a object oriented way, i.e. this guy to be an object, I can use the object version of integers. So right here I can simply say integer, just like that, and now I do have this number. So I could technically say integer equals to new and then integer and then pass 1 there, but this is the exact same thing, right? So here now I can say number and then dot, and check this out. You can see that I now have methods which I can work with. So for every single primitive, right, you have the object equivalent, right? And this will become trivial when you learn about data structures and collections. But basically, just to give you a small flavor of it, so if I have a list, and we're going to cover this later, if I have a list and I want to say that this will be a list of numbers, right, equals to new, or actually equals to null, right? And also you learn about the null keyword. But here, if I want to say that this list can contain basically, so here, so if I import this, so this is what I want to show you. So I can say numbers dot and then add and then 1 and then numbers dot add and then 1 as a string. But if I want to say that this list right here can only contain numbers, right? So whole numbers and nothing else. So the data type of it is just numbers, right? I need to use generics, and this is when I need to say, all right, now I need just integers. Now if I was to type int, right, lowercase, this is a primitive, so this doesn't let me use primitives. I need to use the actual object representation, and now you can see that this is a string, therefore it's throwing an error and I can't use it. So for every single primitive, so double, right, you have double, so this is the equivalent, just like that, right? For long, so let me comment this, so for long, oops, long, you have the actual long class, so long, and basically you get the gist, right? So it's the uppercase version of it, apart from integer, which is the primitive is int and the object is integer, right? But this is pretty much what I wanted to talk to you about in this video. So for every primitive you have the object version as well, so that you can work in a much more object oriented way. But you're going to learn more about generics and lists later in this course. This is just something to keep in mind, and sometimes you might see people use, for example, integers because instead of the actual primitive type, and this is because, right, so there's another reason as well. So if I comment all of this, right, so all of that, and then delete that, so you can have this for reference. So if I also say int and then number equals to null, this doesn't work. However, if I was expecting nulls, I can say integer and then number equals and then to null. And you're going to learn about null pointer exceptions and whatnot later, but you can see that this now works. This is all for now. If you have any questions on this, drop me a message. Otherwise, let's move on.